all the deepest nodes. Yeah, so before solving this problem, we should check that this problem is similar to Leetcode 1123. So if you go to 1123, so we're gonna solve those two problems together, and the only difference is the count rates of the nodes. Yeah, so for 865, so the number of nodes gonna be from 1 to 500, and for 1123, so it's gonna be from 1 to 1000. So that's gonna be the only difference, but the coding gonna be the same. Yeah, because all the values of the nodes are unique, and the nodes values is from 0 to 1000. Let's first try to understand this one, 865, because the description is easier to understand. So we are giving the root of binary tree, so this is going to be the root, and the depth of each node is the shortest distance to the root. And this definition is easy to understand. So for example, the distance, the depth for this node 7, the distance is going to be 1, 2, 3, so it is the longest distance. And for this node 4, the distance is going to be 1, 2, 3, so it's going to be the longest distance. Yeah. So we're going to return the smallest subtree such that it contains all the deepest nodes in the original tree. Yeah. So definitely there are many trees that which contain the deepest node with the 4 and the 7. So for this tree 274, it contains the 7 and 4. But for another tree, what about this tree? The root node is 5. It also includes 4 and 7, but it's not the smallest. We're going to return the smallest, so it's going to be this root 2. So this is our lowest common ancestor problem. So for this node 7 and 4, we need to find the lowest common ancestor. So for the first step, we should know that if we are using a DFS, we can use the DFS to, if there are only two nodes, for example, this is a 7 and 4, we can find the lowest common ancestor. It's going to be 2. Yeah, so this is the DFS part. Let me try to use another color. So this is the DFS part. Yeah. But we also need to know which nodes are the deepest nodes. It's going to be 7 and 4. And for me, I'm going to use a BFS to find it. So I'm going to use a BFS to find which node is the deepest node. And then I'm going to use the lowest common ancestor idea to find the lowest common ancestors of those nodes. Maybe this is 7, 4, maybe there are also other nodes. Yeah, we don't know. Maybe there's other node like 9 or 10, it doesn't matter. Yeah, because maybe it's not only two nodes. Maybe this is a 9 and this is a node 10, and we're going to find 7, 4, 9, and 10. And what is the lowest common ancestor? It's going to be this node 3. Yeah. So this is the same idea. We just need to check two nodes together, and after that we're going to check another two nodes, and finally we're going to find the answer. Now let's just continue to solve the problem. So first of all, I'm going to prepare a DFS, and inside it's going to be node with P and Q. So for this function, recursive function, it is used to find the lowest common ancestor of two nodes with P and Q. So we're going to have a check. So if node inside of the PQ array, so we're going to return the node directly. So if the node not exist, yeah. So if not node, we can return in the node, or we can return the none directly. So now we're going to prepare the left and the right. It's going to be the DFS not dot left with P and Q. Similarly, we can prepare the right side. It's going to be the not dot right with P and Q. Yeah. So if left and right both exist, it means we've already found it. So we're going to return the node. So if there's only left or there's only right, so we can return the left side or the right side. So we're going to continue the recursive function. So this is just for DFS to find the lowest common ancestor of two nodes with P and Q. Now we're going to define another function. I'm going to call it BFS, and this is used to find what is the last layer and how many nodes in the last layer. So for example, the last layer, we have the node 7 and 4. We just need to find it. So I'm going to prepare maybe a queue. I'm going to use an array as my queue. So I'm going to prepare a result. So this is going to be my final result. So I'm going to check the queue. So while queue, I'm going to prepare a level array. It's going to be empty. Yeah, because I want to check each level. So for I in range and length of queue, I'm going to check the node going to be equal to q.pop. yeah, I just want to pop it out and find the next layer. So if not dot left exists, so the level array gonna append this not dot left. And similarly for the right side, if not dot right exists, so the level gonna append with not dot right. Yeah. So after that, if everything is okay, we're gonna assign this queue to the level, and we're gonna check the next layer. Yeah. So finally, we're gonna return the result. So from here, while this queue exists, but this queue, while it goes to the last layer, I need to assign the value, so the result need to equal to queue.copy, because if we directly assign it to queue, and this is only a reference assigned, and this result going to be empty. But if we were to have all the values, so actually this result gonna need to use queue.copy. So yeah, so we just copy it, and this result gonna be everything. Or we can use another copy sign, maybe like this. Yeah, so this is definitely a copy of the queue. And now we have this result array. Now I'm gonna prepare my answer. So answer gonna be equal to result 0 for I in range from 1 to length of the result. Yeah, so currently this result gonna equal to the BFS. Yeah, so while I'm running the BFS, I'm gonna get this result array. This result array basically it is 7 and 4. Now I'm gonna use this 7 and 4 to find 2. So first of all, I'm gonna prepare the first node. It's gonna be a result 0 as my answer. And now I'm gonna check all the possible nodes, and I'm gonna update the answer. It's gonna be DFS with the root and with the answer and with result I. Finally, I just need to return the answer. As you can see, it's a lot of coding, but the idea is just really easy. And the coding is also really easy, and we only need to consider it from here. We need to have the last layer, and we need to have a copy. Now let me just run it to check. It isn't something wrong. Yeah, so let me just check what is wrong with the problem. Yeah, let me just print out the result. Maybe this result is wrong. Yeah, so the result is empty, but as I expected normally, the result should not be empty. Yeah, let me just check maybe from here. Let me just print out the result to check what could be the reason. Yeah, as you can see, it is always empty. It means my function for the BFS definitely it is not right. Yeah, this is because I didn't put anything inside my queue. This means I didn't check. It's gonna always be empty. So for the first one, we're gonna put the root node inside the queue. So we just need to put the root node inside. Now let me just run it. Now as you can see, it works. And let me delete the print and submit it to check if it can pass. Yeah, now as you can see, it passed all testing cases, and it's pretty fast. And for this problem, yeah, this is 835, and the reading is like 1500. Definitely, it's not a difficult problem. Now, we're gonna copy the same code to 1123. Yeah. So the only difference for this problem is that I think the range is from 1 to 1000, and another one is for this one. It's really difficult to understand the description. I mean, if you don't understand the description, so I suggest you can go to problem 865, because this is really easy to understand. Now let's just continue to understand the problem. Yeah, so we are given the root of boundary tree. We're going to return the lowest common ancestor of its deepest leaves. So what is the deepest leaves? If we understand the deepest leaves, it's going to be 7 and 4. And what's going to be the lowest common ancestor? It's going to be 2. Yeah, if we understand it directly, it's going to be okay. But if you try to recall that, it's going to be difficult. Yeah. So the node of a boundary tree is a leaf. This is easy. So the depth of the root of the tree is 0. So here, the depth of the root of the tree is 0. So if the depth of a node is d, so if the depth of a node for this one, it is d equals to 1 maybe. Yeah, the depth of each of its children. So for this children, it is d plus 1. So for here, d equal to 1. So for here, d plus 1. So for this one, it is 2. So this is also easy to understand because we just understand this problem. Yeah. So if you didn't have the background of Leetcode 865, it might be difficult to understand. Yeah. So the lowest common answer of a set S of nodes is the node A. Yeah, S of nodes, it is a set. So maybe 7 and 4, this is a set of nodes. Yeah. It is the node A with the largest depth. So this is the node A7 with the largest depth, it is 3. And for 4, it also the largest depth, it is 3. Yeah. Such that every node in S is the subtree with root A. So every node in S, so for 7 and 4 and in the set in S is the subtree with root A. So it is a subtree of root A. So what is root A? It is the node A with the largest depth. I don't understand it. Definitely I don't understand this one, but I don't think it will disturb me from solving the problem, because definitely if I understand the first sentence, normally I can solve it. Yeah, this is quite confusing, you know. The lowest common ancestor of a set S, it is a set S of nodes. Yeah, it is the node A. I don't know what is node A with the largest depth, such that every node in S is the subtree with the root A. Yeah, so this is the root A. So this is the subtree. Yeah, maybe this is quite confusing for the last sentence, but yeah, I suggest we just need to understand this sentence, and then we're gonna solve the problem, because definitely the problem is very straightforward, but the description makes it really difficult to understand. Now let me just submit it using the same code. Yeah, let me just check. So yeah, let me just use the same code and submit it. Yeah, as you can see, it works and it's quite fast. Thank you for watching. See you next time.